So the first thing to realize is that intelligence is not a linear thing. It's not a scalar. Uh, you can be very smart about certain things and very stupid about others. But intelligence is a combination of many things, right? It's a collection of skills, which is based on knowledge, and an ability to learn new skills extremely quickly, or even to solve problems without having to learn anything. So humans, when facing a new situation, are capable of planning a sequence of actions to arrive at a particular goal without necessarily training themselves to solve that situation specifically. The type of AI systems that we have today, they need to be trained for every task they are supposed to solve. And so whatever they've been trained to do, they're going to be pretty good at it. Whatever tasks have not been trained to do, they're going to be terrible. Which is why we have the impression that, chatbots are intelligent because they can pass the bar exam, or they can, produce poetry or answer complex questions whose answer is in the textbook. But it's because they've been trained with those topics. And there is a lot of training data for those particular topics. But then there are other domains where their answer is going to be completely stupid because they just have not been exposed to that domain. So think of current AI systems as essentially a good interface to knowledge, which is more efficient than an encyclopedia or a search engine or a textbook or a library. Okay, but they don't invent anything new. Now, what people are working on are systems that are capable of some level of reasoning, so some level of being able to solve new problems that they've not been trained on. In my opinion, the kind of techniques that is being developed today in the context of chatbots to do this are very limited, they're very primitive. Ultimately, if you want systems that are as efficient in terms of learning as humans and animals, we need to invent new techniques, which are very different from the ones that are currently used. We get fooled by those systems because they manipulate language very well, and we associate manipulating language with intelligence. But in fact, language is simple. Dealing with the real world is actually much, much more difficult. So that's the challenge for the next few years in AI. Systems that understand the physical world, have persistent memory, are capable of planning and reasoning. Well, yes and no. So no, in the sense that there is a lot to do with LLMs, a lot of applications to develop with them, how to make them better, get them to solve more problems, etc. But there is a little bit too much concentration on it, in the sense that the belief that making LLM bigger, scaling them up, training them on more data is going to lead us to human-level intelligence is false. It's absolutely false. Okay, we're never going to get to human-level intelligence by scaling up large language models. And that can be explained extremely simply. Typical LLM would be trained on something like 30 trillion tokens. A token is like a word, right? So 30,000 billion, okay? Each token is about 3 bytes. So if you do the arithmetics, it's roughly 10 to the 14 bytes, right? A 1 with 14 zeros. That's an enormous amount of text. It's basically all the publicly accessible text on the internet. And it would take any of us several 100,000 years to read through that all that material if we wanted to. Okay. So completely enormous amounts of information. We would think that systems that have been trained with all this data would be really smart. But the problem is, if you compare this to the amount of information that gets to the brain of a young child, it's actually not that big. So a young child, say a 4-year-old, has been awake a total of about 16,000 hours. And there's about 2 megabytes per second getting to the visual cortex from the optic nerve. And you do the calculation, over 16,000 hours, 2 megabytes per second. That's about 10 to the 14 bytes. A 4-year-old has seen as much data as the biggest LLMs. And that tells you a number of things. That tells you we're never going to get to human-level intelligence by just training on text. We're going to have to get machines to learn from video, essentially, or from other high bandwidth sensory inputs. And once we're capable of doing this, which will require new techniques that are not the same that we're using for language, we might have systems that understand the physical world, which means we might be able to build domestic robots, self-driving cars. You know, how is it that a 17-year-old can learn to drive a car in about 20 hours of practice, so we still don't have self-driving cars, and we have millions of hours of training data? That tells us machine learning sucks. Okay, we have to make a lot of progress. So when Yoshua Bengio and I created iClear, we had some pretty bold ideas about what the reviewing process should be. And we thought the reviewing process should be open so that the reviews are published anonymously, of course, and that there should be like a dialogue between the authors and the reviewers, and that anybody should be able to write a review for any paper. And to some extent, you know, we've been kind of holding to that ideal, but sort of brought it down a little bit for reasons that I disagree with personally. But, you know, the volunteers who work on this have to have some autonomy in how they decide how to run things. There is an issue in machine learning, which is that because the field is growing quickly, most of the people in the field are very new to the field. Most of them are very young. Many of them are master students, right, who have very little experience. And they see the reviewing process as being very antagonistic because they got reviews where their papers got, you know, destroyed by reviewers. And so they say, that's the way things are done, so I should do the same thing to the other papers. So that leads to issues where, you know, reviews are not reliable, done fast, and rather negative. And the result is that the papers that are really innovative, that present new ideas, very often get rejected because they're outside the kind of the domain of what everybody is interested in. It's not special to iClear, it's not special to computer science conferences. It's really a general problem that doesn't have any perfect solution. But I wish we did. The research community has fashions, right? So there are things that are popular that a lot of people are flocking towards because they perceive opportunity. I think if you are a young researcher, if you are a researcher in academia, you should try to find other domains that are not as crowded, because that's, you know, you have a better chance of actually making a significant innovation. If you do the same thing that everybody is doing, you risk doing the same research that someone else is doing, or you risk just, you know, producing a very incremental research. So my recommendation to students today who start a PhD or something is do not work on LLM. Like, there's absolutely no point working on LLMs today because it's in the hands of industry. They have hundreds of researchers and engineers working on it. They have tens of thousands of GPUs. There's no way you can compete with this, right? So work on something else. Like, try to make machines more intelligent, understand the physical world. LLMs don't do this. Try to get them to plan hierarchically. LLMs can't do that. Try to work on persistent memory, something that would have the same function as the hippocampus in the brain of mammalians. It's the place where memories are stored, if you want. We don't have any equivalent in deep learning and neural nets today. So, again, those are the four interesting questions: understanding the physical world, persistent memory, reasoning, and planning. Okay, so this is really outside of my expertise. You're talking to the wrong person at Meta. There's an entire team that entirely devoted to designing those systems. And I'm working on fundamental research for like the next generation AI systems. So first of all, people have to understand that the type of machine learning that is used for ranking is relatively primitive. Those are very simple systems. They're not LLMs, they're not like, you know, big systems. They are like fairly simple neural nets. And the reason is, those systems are called, you know, every time you connect to Instagram or Facebook, the ranking algorithm is run to show you the stuff that is most likely to be interesting. And so that's run tens of billions of times a day. And it has to respond to you in less than a second, probably milliseconds, right? So it has to be simple. In fact, at Meta, those algorithms are implemented on special purpose chips that are uniquely designed to just do that, to save power, essentially, and save time. Now, the algorithms that are run there it's a very careful trade-off between a lot of different factors. The first one is content moderation. So that happens beforehand. Like if someone posts a piece of content, are you going to let it go through? Are you going to suppress it? Are you going to just downrank it? And those change over time. So there's a big change coming to Facebook and Instagram about what is done about this. So for example, on Facebook, political content was downranked. Now it's not going to be downranked anymore because it makes sense for people to talk about politics, even if it's contentious, right? Should a company like Meta decide what is factually correct or not? Like should a company like Meta be the legitimate arbiter of truth? And the answer is no. It's not the role of a social network to decide for people what is true or not. Now, there is disinformation that needs to be taken down because either it's illegal, it could be terrorist propaganda, for example, or attempts to corrupt the electoral process. You want to take that down. It could be child exploitation. You want to take that down. Hate speech in Europe, you need to take that down. So there are contents that need to be taken down for legal reasons. There are some that need to be taken down for just reasons that people don't like seeing them and you don't want to show horrible things to people. And then there is kind of the careful trade-off between letting people express themselves, even on controversial topics, but then not letting people basically fight each other online, okay? And there, the thinking about what the optimal setup for this is has changed over time. So at the beginning of Facebook, maybe 15 years ago, there was very little content moderation, and then it started increasing progressively until this year, where it became a little too overbearing. Like some topics were suppressed, which would be totally fine to discuss in real life. So now there is kind of a change to let people kind of discuss topics, including some that are controversial, perhaps in terms that are offensive to some people. It's not obvious, there's no perfect solution. It's a trade-off. Everything is a trade-off.